Okay, well, hello everybody. I'm Liz Farrington, the Marketing Manager at Sensor City. Welcome to our Arrow Comes Home webinar series in partnership with Arrow Electronics. For today's session, we'll be focusing on Industrial 4.0 applications. I'm sure you may all be familiar with the concept of the fourth industrial revolution, being the digitization of manufacturing, but really it's how the systems connect and communicate with each other that produces the smart factories, products and processes that we all know and will be discussing today. We will be joined by 3 guest speakers from Arrow's network. They are all tech vendors and electronics experts. They'll each give a presentation and there will be an opportunity to ask all of the speakers some questions once the presentation have taken place. If I could ask if you could please put your microphones on mute, but do use the chat function within the platform to ask questions sort of as the speakers are going along, and then once they finish they can address all of the questions that are listed in the chat function and we can go through them one by one. The webinar this morning is being recorded, so it will give an opportunity if you wanted to listen again to a specific section, or equally for anyone who's not able to join us live today, they can catch up with it at a later date. So the first speaker we'll hear from today is Petteri Pappsala from ST Micro, and they'll be talking about predictive maintenance and condition-based monitoring. Then we'll hear from 2 speakers from Microchip, Richard Yarnell and Lawrence Barberis, and they'll cover the industrial IoT design and development components, which make all of this smart application and processes possible. So first of all, I'd like to hand over to Petteri. Thank you.
Okay. Thank you. Can you hear me?
Yep.
Okay, perfect. Let me first share my screen and let me know once you can. Can you see my screen?
Yep. Yep, brilliant. Thank you.
Okay, brilliant. So let me still, you utilize the laser pointer also.
Yes, we can.
Okay, good morning. So my name is Petteri Pappsala. I'm part of ET's EMEA's marketing and application organization. So I'm technical marketing for sensor components, analog and low power wireless devices. And in this morning, 25 minutes, I will talk about the ST sensor solutions for this condition monitoring and predictive maintenance application. In terms of agenda, let's look first a bit about what is condition monitoring and on predictive maintenance as an overview. Typical application block diagrams. As you can see, ST has a wide portfolio of devices which are fit there. And as a third item, actually third as a really final item, focus on bits on a new specific component dedicated for vibration sensing devices, applications, IS3, DWB, then just wrap up in the end, and hopefully we have time for some questions as they come and as they're available on our chat itself. Okay, so let's go. Talk about condition monitoring and predictive maintenance for the overview. So basically in an application itself, as you can see today, what is happening a lot, actually in industrial applications, the preventive maintenance is utilized. This means that you have pre-scheduled kind of a maintenance breaks planned for the equipment if there is a need or not. And in this case, the technician is coming, for example, to check the motor vibration with a kind of a portable device. Or then you have on heavy duty devices, you may have a hardwired equipment in place. Obviously, this is resulting in suboptimal maintenance of the application. So for that purpose, the predictive maintenance approach is getting more and more popular, and what we are enabling with ST's components. So in this predictive maintenance, the idea is that we do continuous condition monitoring, sensing. We have mounted on motors and other devices, set of devices, vibration sensors, processing and wireless communication device. So in that way, you can only come and do the maintenance when it's really, really needed. So that will optimize the use of assets. So that's really the hot topic as Industry 4.0 is getting forward. Okay, here on left side you can see some kind of analyst or key numbers. Naturally, all these benefits are application dependent. On the right side, you get a few of the benefits that you will get. First of all, the first on reduced on loss of production time, which is obvious from the previous slide, that you do the maintenance only when it's needed. And then once you do it on optimal time, what actually happens that your machines do last longer, as you can do effective and all the time repairs. And then of course, what predictive maintenance does offer, you can do faster and more efficient repairs already based on the signatures that is being sent from the monitored equipment. You may come there with the right spare parts already in hand, and you can basically fix the device at the same time that the device is saying that it needs to be fixed with the right parts. And then of course, which is really in human perspective, really important, is the increased safety of the workers, that the workers are not being exposed to potentially broken machines, which may be dangerous. In this slide here, quite typically you see in many books the IPF curve. So this is kind of here representing the machine condition at installation phase. And there's kind of a P is kind of the point of change, that something starts to change on the machine condition. And then, okay, the last point here is the failure point. Everything's gone to south, machine is completely broken. So if you go along this curve, you can say that typically first sign is happening at ultrasound level, the first signs of failure. And this you can, for example, capture with MEMS microphones, which we are also offering in our portfolio. Second, you start to sense vibrations, so which you can capture with the vibration sensing accelerometers. And then you may have measurable power differences on equipment, then noise, audible noise, which you can again capture with the microphone components. And then of course, yes, heat, smoke, and then it's too late, the machine is broken. So typically on predictive maintenance, you want to focus here on earlier you detect the failure, better it is, more you have time to kind of schedule the right timely repair for the equipment. If we look at the typical use case of the industrial motor monitoring, for example, first you may detect that there is an imbalance. You may imagine that the motor is driving a fan and one of the fan blades is broken or detached somehow. So this is generating an imbalance for the motor itself, and this can be detected with the vibration sensor. Then you may get the motor loosening from the mounting points. So you detect again different kind of a signature, typically at a higher frequency. And then you may get some output shaft and eventually gearing mesh or gearbox failures which are coming at the highest frequency print. So all these different signals can be captured, of course, with the vibration sensing device, with the accelerometer suitable for that. And then you can do processing, local processing. Typically, these different failure modes are represented on frequency domain as a separate frequency spikes. So this can be actually calculated locally with a local processing MCU, and this will be then shared either with wired or wireless communication methods to the cloud server. And then, of course, what is important, as always, security. So you can actually utilize the secure connections themselves. There are some standards available. For example, for this vibrations for motors, there's the ISO 10816-3. There is also -7 standards, which is quite same for the pumps themselves. And typically in these standards, the measurement points, there are 3 measurement points which are marked here with the blue spots. And traditionally piezo-based accelerometers are used, but the piezo-based accelerometers are just single axis. So you need to have 3 of them mounted in one motor to get all the X, Y, and Z signals available. And then if you look, for example, on specification itself, on this group 2, for example, for the medium-sized machines, and you can have the different zones. A is basically all well from B to C, that there starts to be condition change. Then once you go C to D, there's basically failures. So you can, this is defined as a travel velocity. So RMS velocity can be obtained from accelerometer by integrating the signal. And for example, the 2.8 millimeters per second can be easily measured accurately with our vibrometer and accelerometer sensor devices. Although these ISO standards are in place, a lot of dedicated frequency-based analysis, which is equipment and equipment kind of a signature-based, can be utilized, and there can be cloud computing can be put in place. So in terms of the overall setup, as of today, a lot of signal is actually measured by piezo-based accelerometers, and from the piezo-based accelerometers, huge amount of data is being pushed up to the cloud. Of course, there's a benefit. You have everything available, but there's a huge amount of power consumption in place, and of course, all the data processing in cloud requires a lot of effort. So, kind of the new approach that we are enabling is that we are doing more of the functionality actually in the cloud edge, so utilizing the AI capabilities on microcontrollers, and then utilizing the new devices on accelerometers and microphones that enables the kind of a lower cost point signal gathering that is suitable for this type of an approach. And then only kind of the key metrics are being transferred either with wireless or wired communication. And instead of heavy processing on cloud, you can actually do more like a coding, kind of everything is green, yellow, or then red, something's going wrong. So kind of this indicator marking. Okay, so let's look at the typical block diagrams. So the first diagram here would say that's the on condition monitoring on the right side here. I have a lot of different sensor devices. On top, there's a power management devices, and on the left, I have a communication devices, and then on bottom, protection, and then we have typical microcontroller, which is handling the local signal processing. So as you can see from the right, there's actually quite a few part numbers from ST, a bit more details later on, but there's a accelerometer devices, vibrometer devices, also 6-axis with gyroscope incorporated. We can measure humidity, temperature, magnetic fields, pressure, for example, magnetic field to detect the modes of movement. And then for the ultrasonic microphone, we have analog microphones suitable for that. And then also digital microphones suitable for audible noise and near ultrasonic kind of frequency domain detection. And then typically on the battery operated devices, we'll just want to, we may have a battery charger in application, a high efficiency buck converters to maximize the on time of the device, autonomy time, and LDO devices, low quiescent current or low noise LDO devices to provide the best operating condition for the application itself. Communication to cloud is typically happening through Wi-Fi, or alternatively, you can also utilize the Bluetooth well, especially for kind of a local wireless access to your mobile phone or tablets, or maintenance people mobile phones or tablets in this way. And SD safe and it provides the kind of the end-to-end safe connection. And typically the processor utilized, especially if you run FFT, Cortex M4 or equivalent microcontroller is beneficial as you have the floating point unit for FFT calculation. And then, of course, what is really important is all the protection components for the application that we can offer. Second approach, if you have voltage bus available, example 24-volt bus, then we have a bit different kind of buck converters or LDOs that can be utilized there. And then on left side, you may have RS485 components to do the RS485 interfacing, or then we also support the IO link transceivers from ST side, and then of course you can do also the local connection with the BLE signal communication. But then on the right side, on sensor side, the basic data collection, it's very, very similar. Okay, few words on the really on the key devices. For this kind of unbalanced looseness misalignment use cases, component accelerometer like IS2DH up to 2 kHz can be really good, as well as the 6-axis devices, ISM330 based devices are optimal for this kind of a use cases. For use cases where you need to do actually the FFT calculation, really on this kind of a bearing detection or detection of the different failure modes, the IS3DWB signal, the sensor, is really useful device. I will come more in details of that one. But there you can go up to 6 kHz of signal bandwidth. And once you go higher on more on the ultrasound range, then you can utilize either the industrial digital microphones or analog microphones, which are going up to 80 kHz signal range. On this slide, I will not go to the details, but there is kind of a detailed set of sensors which are useful for the application itself. For vibration, different vibration sensors, 6-axis, accelerometers, magnetometer devices, for acoustic sensing, microphones, and then for environmental sensing, pressure sensors and temperature sensor devices. I will not go more in details of those. What we have to enable customers to trial out, and for, of course, SD components, but also to trial out the application itself. We have this STWIN board available. It's a nickname for a sensor tile for wireless industrial node. On this device, we more or less have the full set of devices as I described on the previous slides, including the vibrometer, the different accelerometers, environmental sensors, processing units, BLE, Wi-Fi boards available, and there is a connection for add-on modem capabilities and RS-485 USB connection, and also SD card for data logging itself. The actually official part number, if you go to ST website, it's STWIN KT1. So that's the official name for this evaluation product. So if you are interested to go and test in your application on this kind of a predictive maintenance, this is highly recommended device to be utilized. Few words on the IS3DWB vibration sensor itself, what makes it different. First of all, against the MEMS and piezoelectric sensors, what are the pros of approaching the application with the MEMS sensors? First of all, they are low power, small sized, and they are low weight. They are cost effective against piezoelectric sensors. So in fact, this enables to utilize the predictive maintenance for a whole range of new applications where it has not been possible utilizing the piezoelectric sensing before. And also there is a digital output. So there's no need for ADC, no need for signal conditioning circuits from the detection to the host processor. And in MEMS, yes, there's a kind of a few benefits. There's a fast recovery time over the shock. The frequency response includes also the DC components, so you can utilize the same device also to detect tilt, for example. Good stability over time, temperatures. There's an integrated self-test always in the sensors, and there's embedded functionalities. Still with the piezo sensors, if you want to go with a really, really high bandwidth, there is a place for piezos in there. And if you have really looking at the best noise or lower resolution, there is still room for those. But as said, the MEMS-based approach, it really, really enables the huge amount of new applications where it can be utilized and also partially replace the devices where piezo is used today. So IS3DWB, it is 3-axis sensors up to 16G can be measured with it, 6.3 kilohertz bandwidth, and then outputs an SPI digital. There's a good noise with the device. Current consumption is higher than typical, I would say, consumer MEMS, but really, really low compared to the piezo-based solutions. There are a few additional features, including FIFO, up to 105 degrees operating range, which makes it suitable to be combined with the motors, and operating voltage typical from the battery. It's a tiny 2.5 times 3 millimeter package. Actually, I will go few of the key items here still. First, the signal chain of this IS3 DWB is fully optimized for the use for the vibration sensing. And also you can see that the noise level is really optimized. 75 microchip per square root hertz, all the 3 axes enabled, and down to 60 when only 1 axis is used. And then for the second and third KPI, the wide and flat frequency band, as you can see here, it's 6.3 kilohertz frequency band is available from the sensor. And what is important on this machine use case is that there's a sharp roll-off to avoid any kind of aliasing effects from higher frequency signals coming from the motor application. So this is well optimized on the device itself. And then the fourth key area is really the stability, the drift over temperature. As you can see, over temperature, the device is staying within this ±2% over the temperature range, starting from the 25 degrees. So it's very well suitable on applications where the temperature is changing, like in the motors when they start to run and when they are off. But really putting this in a short time window, I shared you some key items on the condition monitoring, vibration analysis and FFT, and also utilize the ultrasound for microphones. The new IS3 DWB sensor up to 6 kilohertz that enables whole new range of applications for vibration sensing that can be utilized with MEMS. And this STWIN development kit, that's versatile kit that will allow you to do wide range of demonstrators, as it includes all the components for top of the sensors, also the power connectivity and protection itself. But this is kind of on the window and opportunity to share you kind of on the ST's predictive maintenance application, and of course happy to share you much more in detail on later on what you may want to hear, you may need to know. So I would say thank you from my side, and now it's probably few minutes time for questions.
Does anyone have any questions they'd like to ask? Thank you.
Sorry, Liz. I'd like to ask a quick question, if possible. I'm thinking of a specific application where this kind of thing might be useful for use in my organization. But I was wondering what the usage might be like down towards lower frequencies, maybe around 1.5 hertz, and
yes.
And whether if you go below that point, if using two of the sensors talking together might be able to get more information out if the movement is quite slow.
Yeah. Certainly, if you go for this really low frequencies, on those applications, the vibration kind of a sensor is not necessarily needed, but on these ones, something more like this ISM330 DLC, for example, can be quite handy, where you have really low frequency signals to be captured, as you don't have the risk of this aliasing effect taking that much in place. You may use more than one. I guess you may want to measure this kind of propagation of the kind of the waves, or is this kind of application you're looking at?
Yeah, I mean, I don't want to go too much into the use case, but it's basically a large 2-meter disc that is rocking, and it's supported on 3 actuators. So it's kind of it rocks between all those actuators. That's caused us some issues before. So it's fairly consistent, but round at about 1 to 1.5 hertz, something like that.
Yes. Yeah. Certainly with all the MEMS devices, as we are also capturing the DC signal. So this can be captured. I would probably start to look at this ISM330, maybe DHCX. This is also available, for example, on this STWIN kit. That could be quite useful, and really also to do some data logging and testing, and kind of start to kind of take it off from there.
That sounds good. Thank you. I'll try that.
Yeah. Okay.
Brilliant. One other question that I've had, sort of apart from use on production lines, what other industry applications could you envisage condition-based monitoring and predictive maintenance being used for?
Certainly any equipment. I have some examples here, but traditionally I would say the biggest area is really on the motors. Kind of a motor monitoring, but it can anything which is causing fingerprints on movement. Can be fans, can be kind of gearboxes, you name it. But then of course, if you want to measure something like tilt, there we have a bit different devices offered for that kind of a use cases. Also in industrial, many times that's important, either on static tilt or dynamic tilt. Well, that's a bit of a different topic.
Brilliant. Well, thank you very much. I don't think there's any further questions in the chat, but if anyone does think of anything else, please do continue to ask the questions, and we can always come back to it later on. So we continue with Microchip's presentations, focusing on industrial IoT kind of design and development components. So yeah, if you hand over to Lawrence, that would be brilliant.
Hello, good morning, everyone. My name is Laurence Barberis. I'm Product Marketing Manager at Microchip, working in the microprocessor division. I'm going to make you a quick introduction on microprocessor solution for Industry 4.0. So let me show you the presentation, and give me a hand when you see it. Yep. Okay. So let's give a start. So I'm going to skip that one. I think you all know Microchip. We are a semiconductor provider of total system solution, having a great play in the industrial market, and making every devices, we say, smart, connected, secure, which will resonate for you in Industry 4.0. So Microchip is providing a total system solution, and as hence around our processor as well. And you can see a lot of those solutions will be definitely suitable when you want to build a smart factory. Would that be into networking or wired connectivity options, even wireless, motor control, power conversion, timing, high sensors, touch sensing for human interfaces, and much more. So let's focus on the microprocessor. A microprocessor at Microchip comes from Atmel, actually. We started in 2002 and joined the Microchip family in 2016. We have developed a lot of processor, mostly in the low-end range of the MPU market, with a target to ease the migration of microcontroller, 32-bit microcontroller designed to MPU and Linux, and also with a wish to make things easy as hardware integration as at software when you get started with a microprocessor. So we have microprocessor up to 600 megahertz. We have a very long quality, and we have a lot of very good quality and long life of our products with non-obsolescence. Our first processor in 2002 is still shipping today, and we support the hardware as much as we support the software with Linux mainly. Our processors are industrial temperature qualified, it's minus 40 degrees C to 85 degrees C, but we also have options for extended temperature up to 105 degrees C, and those are external temperature. As I said, quality is important. Our processors are qualified into the automotive grade as well, which gives you confidence on the quality. Trying to make things easy, we're going to go through that in a minute. So let me introduce you a little bit what we're going to talk about. Mainly two processor series. SAMASD2 60 is a new processor variant we've introduced at the end of last year, which is an heritage of a very long story on ARM 926-based processor from us. And the SAME5 series started a bit earlier, but still growing in the family based on Cortex-A5. On both processor family, you'll see a high range of networking connectivity options. Well, we have 10/100 Ethernet, you have dual Ethernet, gigabit Ethernet options, multiple USB, CAN FD, 1588 support as well, and for human interfaces, camera, water control on what's going on the factory, LCD TFT interfaces, and security, something extremely important and in the DNA to what we do since many years. So we'll go through that in a minute. So I said we want to make things easy, particularly on the hardware side. So we make things pretty unique in the industry to reduce the risk of designing with a processor. We are offering options to integrate the high-speed DDR into a single package with the MPU, and we sell those options on both SAME5D2, Cortex-A5 based, or SAMASD2 60 ARM9 based options. And having the DDR into a single package simplifies a lot to design and reduce the risk, specifically for EMI constraints, but also for smaller footprints and reducing the number of layers on your motherboard PCB. We provide examples for that. Those options are offered also in industrial grade temperature. We have a lot of derivatives from low SDRAM density up to 2 gigabit LPDDR2 for more intensive computing needed. So that makes it a great solution, simplifying also the supply, because Microchip becomes a single point of supply for the memory and for the processor. And we have a contract with our memory provider for sustaining the longevity we have in all of the products we sell. So going further into the integration, as you can see on the right side, we also have system on modules. It's pretty unique. We are the only semiconductor vendor that are selling system on modules as well. The idea there is to provide a quick solution for proof of concept, but also those are fully qualified system on module for an industrial production. We sustain high temperature grade as well, and we have different options. We have two system on module based on the SAME5D2, Cortex-A5 based, 500 megahertz operating, and a standard SOM where you can see a system in package with DDR2, the power management ICs on it, Ethernet PHY is on it, clocks and EEPROM for stocking pre-programmed MAC addresses on a standard SOM. On the wireless SOM, we've added more memory, but we also added an interesting wireless communication with Wi-Fi and Bluetooth module on the module, and a security extension with an ECC608, which is a secure element, pre-provision with cloud certificates, and enabling a seamless communication and boarding on public clouds such as Google, Amazon, or Azure. And those are modules manufactured by Microchip with Microchip BOM, and we own the full design. So what makes it a good, compelling story? The system on module can help you build a very easy proof of concept. And because we own all the design, we provide the design files and the schematics free of charge. It's on our web, and you can use it if you want to turn the wheel and make your discrete solution with a system in package, for example. You can reuse the schematics to do your own design with a system in module. Going further, if you will require higher memory density, or other memory requirement, or other cost down requirement on your system, of course, you can go to full discrete solution. And again, with the system on module, or even with helping you on our schematics on our evaluation board, we will provide you design examples to easily and reduce your risk in the integration. That comes also in the future, we have performance upgrades on our MPU and feature upgrade. Those are available under NDA. To support all of that, because support is critical at Microchip, we have master classes. Maybe most of you know that. But from those classes, there are a lot of classes around MPU in the form of getting started with Linux or more Linux expertise, RTOS, IoT implementation, AWS implementation with cloud computing, implementing security, and much more. We have a lot of technical expertise in the field and in the BU to help you or to run dedicated classes if it is required for supporting you. What we have on our hardware side, it's the last point, we provide schematic and design review. So whether you would be required to have an expert in Microchip reviewing your schematics and providing you some guidance, again, to reduce risk and faster design, this is a free of charge service provided by the microprocessor business unit. Okay, one word about Linux. So this is the DNA of Microchip since we started MPU, extremely important to us. We are very well known to the Linux community. We are participating to mainlining and to long-time support on our Linux releases. We support different distributions, and we provide system solutions as well for user interfaces and graphic, security solution for secure provisioning, edge computing and cloud solution with Greengrass mainly. Azure is ongoing, and some connectivity board to evaluate networking capability on the SAMASD2. So a bit more will follow in the presentation. If Linux is not required, Microchip also provides a framework for RTOS with integrated development environment, middleware, and examples of RTOS implementation on MPU. And those also support ThreadX or FreeRTOS if and when real time is of concern. So let's look at it a bit. For an industrial automation, or for, let's say, industry 4.0, in our view, a few things are definitely critical with building a system around an MPU. Taking care of a good human-machine interfaces, thus is supported with the capability of the hardware, but also with what we provide into the software solution for building your UI. Would that be under an RTOS or with a Linux framework? We provide license-free graphical toolkit to manage the human-machine interface. I think something very popular is what we call cloud connectivity, of course, IoT connectivity to manage things remotely, and cloud and edge processing, cloud edge processing into the local gateway, something we're going to talk about. Networking is critical. So we have a lot of embedded features in the microprocessor, but we have also a huge portfolio of external components to support a lot of industrial protocol, which my colleague Richard will go through at the end of the presentation. When we talk about deporting cloud function locally to an edge or connecting to a cloud, and even for operation security, it's extremely important. And we have a lot of embedded solutions in the processor and solutions to help you building this securely. So one word about security. Well, you can trust us. We are supplying microprocessor in the industry, in the payment industry for 30 years plus. So our processor are used in payment terminals. We are serving the #1 OEM in this industry for years and developing processors that match this requirement, which are very high. So the embedded security of the processor are verified by third-party experts. And they are not only used in payment industry, but nowadays in a lot of other industry and vertical industry that requires to secure the communication, the data, authenticate the firmware, and being able to also do secure firmware updates while in the field. And this is very critical when you have devices deployed for 15 years plus. You need to be able to patch. So those are very important. All those features you can use. If you want to make some easy integration of security, well, Microchip has partnered with Sequitur Lab. It's a company who is providing EmSpark IoT Security Suite, fully tailored to our SAMASD2 processor and utilizing the embedded security feature, and therefore providing simple API in Linux environment for you to do some secure provisioning, controlling certificate management, secure key storage, secure data storage, and firmware upgrade out of the box, basically. Again, making your integration easy. You can refer to Microchip pages on the presentation you'll get for more information. So edge computing, well, I guess probably most of you know that cloud computing is extremely popular, aggregates a lot of data from various nodes and do intensive computation and calculation on the data to make decisions locally. Those clouds are private or public. Probably all of you know Microsoft Azure or Amazon or Google and some others from China. So cloud computing is great, but being able to deport those cloud computing function and software locally into a local edge or local gateway is extremely popular. The advantage of doing this is have a faster response time and more reliable system, so that you do not depend on the quality of your WAN or a connection to take decisions locally, and that's very important for reliability of the system. Also, when you locally compute data collected from nodes, you don't need to have a constant data flow with the cloud provider. So you reduce the data bandwidth usage you're doing, and then you're hence reducing your cost dramatically as well. Eventually, what the cloud vendor provides is the ability to develop the software once. So every cloud function developed in the cloud can be easily ported locally into the local target. This is what Amazon has done. It's called Amazon Greengrass Edge Computing. We started to partner with them, and we are working with Azure for the future. So this is how it looks like. I mean, this comes from Amazon, just to give you a little bit what it is. So hand nodes communicating locally to a gateway that locally compute cloud function and make decisions, and eventually sync only occasionally to the cloud, can be once a day. This is what Microchip has done. We have partnered with Amazon with providing, and we worked with our SAMASD2 hardware. We have made a demo, was available for embedded world, where we connect nodes wirely or wirelessly. And you can see a lot of hand nodes here being presented from Microchip. Those are 8-bit. We have a lot of 32-bit nodes, depending what function you need to do. Connecting to the gateway, and the gateway is running IoT Greengrass core from Amazon to do local compute function of the data transmitted to the node, and syncing occasionally to the cloud. So our SAMASD2 platform are fully compatible with AWS Greengrass. We are referenced on their website. And either system on module with wireless extension or our standard evaluation board, you can take them and start easily a Greengrass edge computing on those components. Also, so supported by Amazon. We have application how to get you started on our evaluation pages. One word about that one. So this is a wireless system on module, and basically with a connected, you have wireless connectivity, wired connectivity with a 10100 Ethernet, the power management IC, the processor, but also a secure element, which is called CC608, which is pre-provisioned with cloud credential, enabling you to automatically connect your system to the cloud without doing any further action. Azure is something we're working on. We're working on edge computing with Azure right now. I mean, they are working on our platform because they liked it. And this is a demo where the SAMASD2 processor can be seen as a high-level node, capturing a hard sensor rate and connecting very seamlessly to the cloud with a secure element and providing the data to Azure Cloud. On the user interface side, I think I mentioned, so we have a graphical toolkit running on top of Linux. It's called EGT, fully released now. It's free of charge, and it is really fully optimized to use Microchip hardware underneath hardware capabilities, such as overlays, LCD controller, video decoding. A lot of library are provided to build very simple UI for interfacing with the operator in a factory. Support and training resources are also available from Microchip as providing then a complete system solution. On the networking side, we have developed a specific demonstrator, an evaluation platform with a lot of different components to do wired networking from Microchip, again, to prove the total system solution. This board is supported in our Linux framework. So all the drivers and everything is working out of the box, and you can reuse, of course. And that can be used to evaluate performance or the system you want to build with EtherCAT or Ethernet switches, certain bridges to gigabit, multiple USB ports, or CAN transceiver, secure element are there. And it's a great platform to evaluate a SAMASD2 processor in an industrial environment. This is the board. I'm not going to go through all of the detail. You'll have that in the presentation. You have its picture on the top right corner, where you can see the multiple interfaces that you can enjoy to test the processor. So lastly, for Embedded World this year, we didn't have the chance to attend, as you all know, but we wanted to be focused on Industry 4.0 very specifically. And we have built a demonstrator to show the complete total system solution of Microchip around that for those solutions. And this is a robot arm, as you can see, with a pegboard controlled with one of our 32-bit microcontroller and a camera to control the placement of the little units. And this is controlled through a local gateway as a SAMA5D27 system on module evaluation board, taking the data and connecting them for different options, either as an access point with your mobile phone or connecting with Wi-Fi to a cloud gateway. And here that was Amazon, to demonstrate full functionality from the node to the cloud function, using all the different equipment and elements Microchip can provide. The demo has been filmed, as we couldn't demonstrate it live, and you have the link here. And all the BOM costs and all the resources and the software to build this demo are available on GitHub. So I can invite you to have a look. And that is, again, to make the integration easy and to make you started without risk with an Industry 4.0 system. So that's a bit what I was for my part. I'm going to let a very quick summary. Microchip MPU have a best-in-class Linux support, where RTOS is also supported in-house with complete system solution. System and package and system on module reduce your risk and fasten the design very greatly. We have great low power consumption feature and on-chip security you can use with solutions around it. And we are one-stop shop for all the tools, the silicon, and the software. So regarding the wired connectivity options, I'm going to let the talk to my colleague Richard right now.
Hello again. Right, let's see if I can share my screen. Right, so I'm Richard Jarnell. I'm one of the apps engineers who covers what's called UNG, which is USB and networking products. This encompasses wired Ethernet, USB, and EtherCAT. I thought I'd concentrate, because I've got a lot to cover in 10 minutes, I thought I'd really just try and concentrate on the Ethernet and the EtherCAT products that we've got. So we do have USB products. If it's something you want to talk to me about offline, or if there's any other subjects that you want to talk offline, then please feel to reach out. So the UNG Product Group mission is basically to make it as easy and simple as possible for people to come to market with their products. So we get our products typically certified in the University of New Hampshire. We develop internally our own software and drivers, so demonstration. We also support the Mainlined Linux kernel, and we also provide evaluation boards, and also a service called LAN check and USB check, whereby a client can submit their Gerber files, their schematics, and their bill of materials, and our validation engineers will actually look at them and give you feedback on that. So we find our clients really find it useful, especially for high-speed designs where they may well need just a little bit more help. So that's a service that we offer completely free of charge. As far as the portfolio is concerned, as I say, I haven't got a lot of time, so this is just really an overview. So we offer switches, which go from 3 to 52 ports. We support 1, 2.5, 10 gig and above. We've got controllers, which allow an MCU with either an SPI or a parallel interface to communicate across Ethernet. We also have USB and PCIe bridges, which allow you to go to 10/100 or gigabit. And we've also got microcontrollers, which support them directly. So we have got a wide portfolio of products. I'm seeing really at the moment within industrial, the majority of the products tend to be using 10/100, and there's a certain move to 1 gigabit. I'm not seeing a lot in 10 gig apart from sort of higher level stuff, so SCADA and more higher function devices. So at the moment we're really seeing mainly 10/100 and more gigabit. Most of the existing field buses tend to be based on 10/100. So this is a quick overview of the Microchip / Microsemi Ethernet products. This is Microchip bought Microsemi a couple of years ago, and that brought a massive range of products to our portfolio. So we can go from 10/100 single port PHYs, bridges and controllers, right the way through to 64 ports at 25 gigabits per second. So whatever your requirements for switches are concerned, come and talk to us. Ethernet bridges, this is a technology which really allows you to go from one type of interface to another. So for example, USB 2 to 10/100, USB 2 to gigabit. One of the benefits of doing that is obviously with USB 2, you've got a bottleneck of 480 megabits. By going to gig Ethernet, then it'll allow you to typically get about 350 megabits from a USB 2 port. Then we've got USB 3.1 to gigabit and also to RMII. We see a lot of clients who want to go from USB 3.1 or USB 2 to MII so that they can use, for example, T1, T1S PHYs for single twisted line multi-drop applications, and also to a certain extent we've seen a lot of interest in Li-Fi communications where they're going from RGMII across to basically a power line modem. PCI Express to RGMII or Gigabit Ethernet, that's new products from us. I'll talk about those in a few minutes. And then we've also got controllers. So the controllers typically implement a USB interface to 1, 2 or 4 USB ports. So you've got hub and also a 10/100 controller. That was actually designed, one of those parts was designed into quite a large, well-known UK compute platform. And we sold over 20 million of the devices, and I don't think we've had a single device fail. Okay, people have done stupid things like connect 240 volts into the port, but that's not something we can do much with. But yeah, we've got lots of different controllers. EtherCAT is something I'll talk to you about in a few minutes. This is our bridge, PCIe to Ethernet bridge. The benefit of this is the majority of the market for PCI Express to Ethernet tends to be from the compute market. So what happens is the majority of manufacturers will come to market with a product which might be PCIe to multi-Ethernet, whatever, but they'll introduce it with a known end-of-life date. With Microchip, what we do is we'll bring a product to market, and as long as we've got clients for that product, we do not discontinue it. So instead of having to go through a redesign every 5-7 years, by using us, we can guarantee longevity for 10, 15, 20 years. So if you're looking at implementing PCIe, then this is really worthwhile looking at. We've also got drivers that we've developed in-house, so we can fully support the parts, and it's also mainlined in the Linux kernel, and it's also supported with Microsoft. So it's in box with Microsoft. These are our switches. So we've got 3-port here. So we originally we created the 7-port switches to start off with for gigabit. So we've got the standard one, which is a standard 6-stroke 7-port device. We've got a device that supports what's called EtherSync or IEEE 1588. And then we've also got another design which we created specifically for industrial designs, which implements redundancy as well as 1588. What we've done with this part is also have an an offload engine to effectively look after the majority of the hardware to do the redundancy functions. So once we created these, we then introduced a couple of smaller ports which are based on the same technologies. So a standard 3-port and a 3-port with IEEE 1588. And then on the 10100 side, we've got a number of various different devices. This one's quite a useful part, the KSZ9897 family. We designed this so you got a 1 gigabit upstream and 4 10100 downstream ports. The benefit of that is instead of having a 100 megabit bottleneck coming into the switch, because you've got gigabit coming into it, you can actually service the 4 ports or 5 ports at full 100 line speed. The landline 303, that's an interesting part. If you've got a design where you're already using a switch and you want to fairly easily add a second port to that, so if you've got a design where you've got a single PHY and you want to add an extra Ethernet port, then this is a device that's really easy to use to add that second port. We've got evaluation boards for the gigabit, well, with all products. At the moment, we're really putting the majority of our focus to, as far as standard switches, into gigabit and above. So we've got 2 platforms. We've got an unmanaged switch and a managed switch. The managed switch has a Linux subsystem which controls the switch. The switch on here is the top of the end 7-port device. So this board actually supports all of the functionality, and what we've also got is software that actually supports a standard Linux driver. We've got PTP, IEEE 1588 support, and we also support DLR and HSR. So we can provide software directly for that board, which will allow you to fairly easily work and implement DLR, HSR, IEEE 1588, etc. And it's really easy to use. If anybody's interested in talking about this, then I can spend some time talking about that. EtherCAT, I just really wanted to very quickly touch on. EtherCAT's basically an industrial field bus system. It's free to join. There's over 5,500 members of the EtherCAT technology group. It's free to join. You get free tools to create the slaves. There's also worldwide plug fests, so you can do a design, take it across to a plug fest, test it with other slaves, other masters. But it uses specialist low-cost slaves, and the master itself just uses a standard Ethernet MAC, so you can run You can run a master on a Raspberry Pi running Linux. You can buy, well, you can get hold of various different free of cost master stacks, and it's very cheap to implement. It also offers you 1 microsecond or better timing across the network using a mechanism called distributed clocks. Now, this comes free of charge. It also supports up to 64K nodes on the across the network, and it runs at 100 megabits per second full duplex. It's become a standard in the Chinese market, and it's really basically been designed from the ground up. This is an idea of our portfolio. So we're really concentrating on the EtherCAT slave side of things. So we've got a number of devices that we can offer. We've also got evaluation boards. We also have support software for various different processor architectures. And we can basically fit in all over the place. So if, for example, someone's developing an EtherCAT master, then that's an ideal opportunity for the PCIe to Ethernet controller. If somebody else is using various different other controllers, we can offer PHYs. We've got our standalone LAN 9252 and 9253 controllers and 4. And this is basically where we are at the moment. So we've got the LAN 9252, which we introduced a few years ago, and then we've basically spun out a couple of new devices. The main difference between the two new devices is that they basically give you faster access to the devices. The LAN 9254 also provides you more digital inputs and outputs. So using the digital I/O, you can very easily, with basically a one-chip solution, create a slave with up to 32 digital I/O. EtherCAT P is a fairly new standard that's come out. EtherCAT P allows you to basically put 2 24-volt supplies across the receive and transmit pairs. So instead of having 2 cables, you've just got the one, and that allows you to power the devices on the network as well as send data. And this is an evaluation board that we put together. That was just a quick run through. If anybody wants to know any more about EtherCAT or any of the products that I've talked about, I've got a 2-hour class that I normally run. I'd be more than happy to run that. I can have a chat offline about EtherCAT. I can give you a really good understanding of how it works. So yeah, feel free to ping me an email. It's richardyarnell@microchip.com. But thank you very much for your time. I'll pass it over for any questions.
I'm not sure if we do actually have any specific questions posted in the chat. If anyone does have any questions, please do flag them up now. Well, if you do have any other questions, you can certainly email them through to me and I can pass them on and link you in with the speakers. I would like to say a big thank you to all of today's speakers for their detailed presentations. It has definitely been interesting to hear about the different sensor components, processors and modules that have been used for digital transformation and the different uses in maximising AI, cloud computing, big data and IoT, helping to bring products to market. So I hope you have found it interesting as well. And I do certainly thank you for joining us today. We will be circulating the slides so you can look at certain parts in more detail if you'd like. And there will also be a link to the recorded session, which I will share in the follow-up email, which you're more than welcome to pass on to your wider networks and colleagues if they would also find it valuable. Our next session is this time but in 2 weeks. It's focusing on the electrification of transport, and that will be again starting at 10 AM on Tuesday, the 16th of June. So please do register. All of our webinars are free, so it's available to sign up to now, and we'd love for you to join us then. All details of the remaining Arrow Comes Home webinar series are available on Sensor City's website, which is just sensorcity.co.uk, and you can find details of the online events and more about what we do all there. So thank you again. Hope you've enjoyed it, and we'll hopefully see you again in 2 weeks' time for the next Arrow Comes Home webinar. Thank you.